Hey, welcome back everyone. In this video, I'm going to show you how to log events using a singleton in a clean, scalable and maintainable way that will make your life much easier in the future. For that, I'm going to be adding logs to an open source project that I have in GitHub called the ISSTracker, which is a very little app that tracks the position of the International Space Station in real time. And I will be improving it in this video and the next ones with more features and refactors to improve the code's quality. Alright, so over here I want to show you how the ISSTracker project is architected. Here we can find 5 different modules: the ISSTracker feature module, API module, composition module, presentation module, and the UI module. To understand the arrows, the dotted arrow means that some class is implementing an abstraction, and the straight arrow indicates that a class has a dependency on the other class. So in this case, I want to start adding logs to my project, and the first place I want to start logging is the network layer. If we zoom in into the API module, we can see that we have a remote ISSTracker loader that depends on an HTTP client abstraction, and we have the Alamofire HTTP client that conforms to the HTTP client abstraction. If we didn't see the previous video where we talked about how not to log analytics events, we would go to our Alamofire HTTP client, and in our getData method, which is the method used to perform requests, we would do something like logger.shared log event performing request. But there is a much better way to do it. Instead, what we want to do is we don't want to modify the current class, the Alamofire HTTP client class, and we're going to be implementing a decorator in between the remote ISSTracker loader and the Alamofire HTTP client that will exclusively log analytics events for every request. So if we zoom in to the API module, we will find the remote ISSTracker position loader, which contains an implementation of an HTTP client. And then we have the Alamofire HTTP client that conforms to the HTTP client abstraction. We can check our app composer enum, where all our instances are composed. The remote ISSTracker position loader is injected with an HTTP client, which in this case is the Alamofire HTTP client. And the idea is that our EventsLoggerDecorator gets injected in between the remote ISSTracker position loader and the Alamofire HTTP client from the composition root. So the app composer is the one that is in charge of instantiating, and we want to have a new class, EventsLoggerDecorator, which will go in between, will be the one that will hold the concrete Alamofire HTTP client class, and the remote ISSTracker position loader now will be injected with the EventsLoggerDecorator. The EventsLoggerDecorator will conform to the HTTP client abstraction, so the remote ISSTracker position loader will call events from the EventsLoggerDecorator, which will be in charge of logging, and will forward those calls to the Alamofire HTTP client class. And then going a little step further, the EventsLoggerDecorator will contain a logger abstraction, and it's going to be the concrete logger that we implemented in the previous video, which will actually log the events, which we're going to rename to ConsoleLogger. The first thing we're going to do is we're going to create a new tests file, and we're going to call it EventsLoggerDecorator tests. We're going to eliminate the boilerplate code, and we're going to start with the test, and we're going to call it test calls logger on log event. So following the given one then structure, starting with the given section, we're going to implement our decorator as a struct. In the when section, we're going to call the login method. which is going to be called the log event. So let's go ahead and implement our login method, which is going to receive a message of type string for now. And then we want to assert that the logger was invoked when we call the logging event of the decorator. So we can do that by having some kind of boolean, which we can name did log event, and we can initialize it to false. And now we need a way to inject a logger to our EventsLoggerDecorator. For that, we're going to create a variable logger, which is going to be of type logger, which we're going to be injecting with constructor injection. And now in the logging event, we want to invoke log event with a message. The strategy here is that we want to inject any kind of logger to our EventsLoggerDecorator. So for that, we're going to define an abstraction, and this abstraction called logger is going to have our logging event method. Now we need to inject the logger that we want to use, and for testing purposes, we're going to implement a struct dummy logger, which is going to implement the logger abstraction. So we can have some kind of closure that can be invoked, and this closure does not receive arguments and does not return any arguments. Now we are in conditions of injecting this dummy logger, and in the callback we're going to be setting our boolean to true, which is the behavior we want to achieve right now. Let's run the tests, and it's passing. But since we want to see a failing test first, we're going to comment out the logging event, run the tests again, and there we have a failing test. Put it back, run the tests again, passing. So now we can commit our changes, implement EventsLoggerDecorator with its tests. Now we can move our production code. We can create a new group and call it logging, and inside we can create our production file, and there we have it. Now if we go to our tests file, we're going to see that the tests file cannot find the decorator because we haven't made it public yet. So we can go back and make our protocol public, as well as the struct and the log event method. Of course, we need to import our module, and the compiler is complaining that we don't have a public initializer. So we can go back and do that. And now we can run the tests again, and they're passing. Awesome. Alright, so we have our EventsLoggerDecorator, but as you can see, it's not decorating anything. We don't even have a decoratee to decorate. The strategy here is that this decorator is going to be implementing abstractions and decorating by logging those abstractions. So we're going to jump to our API section, HTTP client protocol, and HTTP client is the abstraction that we want to implement with our EventsLoggerDecorator. So if we go back to our logger and we make it implement this abstraction, we can create an extension. We will have to implement the getData method from the HTTP client abstraction. We're going to invoke the log event method, and we're going to log performing request. We need to import foundation. So here we want to forward our getData call to our decoratee, which is going to be a generic type. And now we need to tell our extension that T also implements HTTP client. We need to add our decoratee in our constructor. And there we have our decorator that receives an object of type logger and a decoratee of a generic type. And we have extended our decorator to implement HTTP client, and also added the conformance of our decoratee to HTTP client as well. Now we need to go back to our tests, and we're going to have to modify our given section because our EventsLoggerDecorator now also receives a decoratee. Since we don't want to be breaking our tests very often, what we can do is we can refactor and implement a factory method. We can create an extension. We can implement a make SUT method, which is going to return an EventsLoggerDecorator, and we can pass the closure. And now we need to add our decoratee. And since we don't care about the type, we can just implement a decoratee that implements encodable, which has no methods. We can pass it in our constructor. And now we can follow the compiler. Our closure needs to be escaping. We need to define the generic type of our EventsLoggerDecorator, which is going to be encodable. We can refactor to just return our instance. And any refactor we do in the future, we're just going to have to change our factory method, and we're going to leave our test untouched, which makes them more robust. So we can run the tests now to see that everything still passes, and it does. I want to emphasize here the power of the abstractions we have used. With the logger abstraction, we could create a dummy logger, and we could inject it with constructor injection to our EventsLoggerDecorator, avoiding having to print events to the console, as we would have done with the static accessor of the logger we implemented in the previous video. Since we have finished refactoring, we are ready to commit again. So extending EventsLoggerDecorator to implement logging in HTTP client events. Cool, so now it's time to bring our ConsoleLogger that we implemented in the previous video. I'm going to create a new file for this one. We're just going to rename it to ConsoleLogger. And there we have it, implementing ConsoleLogger. You will probably notice that we don't have any tests for this ConsoleLogger, and that's because the only thing this object is doing is printing to the console. And since the print method is a native method and it's being tested already by Apple, we don't need to be testing it again. I'm happy to just leave it without any testing for now. Now it's time to compose everything in the composition layer, our composition root. So we're going to go to the main section, App Composer. Now look how easy it is to change our composition and start logging HTTP client events. So since our EventsLoggerDecorator implements HTTP client, same as AlaboFire, we can instantiate it right here. Now we need to inject a logger, and we're going to use the AlaboFire HTTP client as our decoratee. Now we're going to inject the ConsoleLogger, and we're going to change the HTTP client variable with the EventsLogger. Now the compiler is telling us that the ConsoleLogger does not implement the logger abstraction. So we're going to go and do that right now. Now the compiler is not complaining anymore. And with these few changes in the composition, we managed to start logging events in every request without modifying our HTTP client implementation, respecting the open-closed principle of Solid. Open for extension, closed for modification. Let's run the app. And there we have the International Space Station, and we have the logs in the console, which confirms the composition is working as expected. Okay, let's go and commit. Conforming ConsoleLogger to logger abstraction and composing ConsoleLogger in composition root. Again, I want to emphasize that we did not have to modify either the AlaboFire HTTP client or the remote ISSTracker position loader to add logs to them. Instead, we composed the EventsLoggerDecorator using the ConsoleLogger, as a middleware between the loader and the HTTP client. As a bonus for those who stay till the end, I'm going to show you how powerful the composition and the abstractions are for a project. Instead of logging events to the console, I decided I want to start logging events to Firebase. So I implemented this Firebase logger, which imports Firebase Analytics and Firebase core dependencies in the private initializer we call the Firebase app configure to set the settings of our project. And same as with the ConsoleLogger, we have a shared instance, and we made the Firebase logger conform to our logger abstraction. And finally, instead of printing to console, we are calling the analytics log event method, which will send our message to the Firebase backend. Now look how simple and powerful it is to change our console logger with our Firebase logger. So we're going to go to our app composer, and in here we're going to rename console logger with analytics logger, which is a more descriptive name. We just have to change the shared instance of the console logger with our Firebase logger shared instance. Let's run the app. And right here we have our performing request event. We want to check this in Firebase, and there you have the events performing request, and they're nicely being logged into Firebase. That's it for today, mobile developers. I hope you enjoyed the video and that you find it useful, and see you in the next one.